Okay, now let's look at graphing transformations of exponential functions. We're going to look at three types of transformations: vertical shift, horizontal shift, and reflections. Now, graphing a vertical shift of a parent function involves adding a constant d to the parent function f of x equals b to the x, where the vertical shift d happens the same direction as a sine. Okay, so let's consider the vertical shift of this function to the x again, where it's in blue. And we're going to actually look at these orange function, or h of x to the x minus 3. Let's look at the transformation to the x minus 3. The transformation looks like from the blue graph, the orange graph went down 3 units. So it's a vertical shift down 3 units. The domain is the same. It's going to be negative infinity to infinity. The range, the lowest y value this time, it's going to be starting at the y, the horizontal asymptote. It's negative 3 infinity. The y-intercept, it looks like it's intercepting the y-axis at 0, negative 2, or just negative 2. The horizontal asymptote, the original asymptote of the graph to the x was at y equals 0, but because your whole function shifted, the horizontal asymptote also shifts down as well. So it's going to be y equals negative 3. Notice here that your range value, this value, is always going to match your value of the horizontal asymptote. Okay, so in general, with vertical shifts, the domain of negative infinity to infinity remains unchanged. The y-intercept is going to change. The horizontal asymptote is going to also shift up or down depending on your vertical shift, and your range also will change. Okay, now let's take a look at horizontal shifts. Okay, so horizontal shifts, we add a constant c, so a number c to the parent function, the input of the parent function, b to the x. And we're going to get a horizontal shift c units in the opposite direction of the of the sign. Okay, so this parent function, this is our parent function 2 to the x, and we're going to look at h of x equals 2 to the x minus 3. Well, this time the minus 3 is attached to the input, or the exponent part. The transformation, it looks like, is shifted right 3 units. The domain is negative infinity to infinity. The range is 0 to infinity. The y-intercept, it's unclear what the y-intercept is, but we can calculate it by substituting or evaluating h of 0. So 2 to the 0 minus 3 is 2 to the negative 3, which is 1 over 2 to the third, which is 1 over 8. The horizontal asymptote, again, is y equals 0, because the original horizontal asymptote, if it just shifts to the right, it kind of slides on its own, on itself, I should say, so it's the same. So in general, with horizontal shifts, the domain is negative infinity to infinity, remains the same. 0 to infinity for the range also stays the same. The horizontal asymptote also stays the same, but the y-intercept is going to be different. Okay, let's look at here, next example together. Let's graph f of x equals 2 to the x plus 1 minus 3, and identify the transformation, domain, range, and its horizontal asymptote. It doesn't ask for us to do it, but I'm going to graph the parent function to the x, and we know that it's at 1, 2, and to the 4th, and it looks like this. So there's our parent function y equals 2 to the x. So using these 3 points, I know if it's x plus 1, the transformation is to the left 1, and the negative 3 is down 3. So let's move each point to the left 1 and down 3. 1, 2, 3. So this point, left 1 and down 3, left 1, down 3. And the original horizontal asymptote was at y equals 0. But this is also going to shift down to y equals -3, which is right here. So using that as a guide, my exponential function f of x is going to look like that. Now the domain is -infinity to infinity. The range is -3 to infinity. The horizontal asymptote is y equals -3. You can also graph this using your graphing calculator. And let's head over to the calculator and graph this together. Okay. So it was, we can compare to the original function. Let's put the parent function down to the x and compare it with our new function 2 to the x plus 1. And then we got -3. Okay, so there's our original function. You can see our new function. If you want to, you can also go to table and see how the values differ. All right, let's head over back to our main page. Okay, example 7, I would like for you to try on your own. We'll compare our answers in class. Okay, so the last transformation we'll look at together is graphing reflections. Reflections involve reflecting about the x-axis or the y-axis. So if we have a parent function, we're comparing it with f of x equals 2 to the x. If we have -2 to the x, we get a reflection about the x-axis. When we have 2 to the -x, we get a reflection about the y-axis. Note that also we can write 2 to the -x as function y equals 1 over 2x. Because remember, 2 to the -1 and 1/2 are basically the same thing. So if we compare the functions here and identify its domain, range, y-intercept, and horizontal asymptote, we're going to look at the function that reflected about the x-axis. So we're just considering -2 to the x. Its domain is -infinity to infinity. The range this time, because it keeps going down, it's going to be -infinity to 0. The y-intercept looks like it is crossing at -1. The horizontal asymptote is going to be at y equals 0. So it's the same as the original parent function. Now let's look at the function where it reflected about the x-axis. I'm considering h of x to the -x. The domain is -infinity to infinity. The range is 0 to infinity. The y-intercept looks like it's the same at 1. Horizontal asymptote looks like it's also the same at y equals 0. Okay, for example 8 says to graph g of x equals -2 to the -x, and we want the transformation domain, range, and horizontal asymptote. This one also I would like you to try on your own, and we'll compare our graphs and the transformations in class. Okay, we'll stop here, and then we have one more video for this unit, and I will see you back then.